So we're going to continue our study of radical functions. And today we're going to look at, for the first time, what it means and how we would solve equations that have radicals in them. So let's look at our objectives here. The first is to solve square root equations. Now we'll actually look at two cases, but in this lesson, we're going to work first with just square root equations. In the second part of this lesson, we will work with equations that have rational exponents, but for today, just square root equations. And then also certain types of equations, we need to check for what we call extraneous solutions. All right, so what is a radical equation? It's an equation that has a variable as a radicand or a variable with a rational exponent. So if the radical has an index of 2, then we would call that equation a square root equation. But we could have other indices. We could have an index of 3, that would be a cube root equation, and so on. So let's look at some examples here. 3 plus square root of x equals 10. We notice that the variable is in the radicand, so this would be a radical equation. Let's look at another one here with a rational exponent. So x minus 2 all raised to the 2/3 power equals 50. So we have a variable with a rational exponent. How about this equation? It has a square root, but notice that the variable is not part of the radical. So this would not be a square root equation. And let's look at another example here with a rational exponent. 5 to the 1/2 plus x equals 1. So again, it has a rational exponent and a variable x, but the exponent is not applied to our variable. So this is not a radical equation. All right, here's a few examples. See if you can figure out which ones are radical equations and which ones are not. All right, so A is 3x inside the radical. B is 2x minus 1 raised to the 3/2. C is not, right? The 5x is not inside or part of the radicand. And D is 2x is being raised to the 1/5 power. All right, let's try 4 more here. All right, A is, right, we have x as our radicand. B is not, right, x is not inside the radical, it's not part of the radicand. C is, x is being raised to the 1/4 power. And D is not, right, the 1/2 exponent only applies to the integer 4. All right, so what is our strategy to solve a radical equation? Square root of x plus 25 equals 4. Now, the challenge is we can't do the normal things right off the bat in terms of getting x by itself. You might say, well, we just subtract 25 from both sides. But we can't do that because the expression x plus 25 is inside the radical, and the other side we just have an integer. So the first step is, how do we get rid of the radical sign? Okay. Now, before we even do that, we want to make sure we have just the radical expression or the radical with the radicand on one side of the equation. Now, in this example, we already have that case, so there's nothing we need to do to isolate the radical. So now we're going to go to the next step, right, which is, how do we get rid of the square root? Well, what is the inverse operation of taking the square root of something? It's raising it to the same power. In this case, since our index is 2, we're going to square both sides. So here's what that looks like, right? We're going to take the whole radical on the left and square it. Do the same thing on the right side of the equation. So squaring the square root, those are inverse operations. They basically cancel each other out, and we're left with just x plus 25, and then 4 squared, of course, is 16. Now we have a very simple equation we can solve, right? So we're going to subtract 25 from both sides, and we see that we get a -9. Now, it's always good to check your solution. So let's take that -9, plug it back in for x. So -9 plus 25 gives us a positive 16, and that does indeed, the square root of that give us 4. All right, let's look at a little more complex example here. Notice we do need to do a few steps to get the radical by itself. So we have a 2 that we're adding, and we have a factor of 5. So what do we do first? Well, first step is to subtract the 2 from both sides, okay? So we do that. Now we divide both sides by 5 to get just the radical by itself. So 15 divided by 5 leaves us with 3. And now we can square both sides. So let's go ahead and do that. So we square the entire radical, and we square the 3 on the right-hand side. So we get this equation, easy to solve, right? We're going to add 3 to both sides and then divide by 3, and we get our answer of 4. And then let's check our solution. So if we put in 4 for x, right, we'd have 12 minus 3 is 9. Square root of 9 is 3, so that's 15 plus 2 is 15. I'm sorry. Oh, I subtracted the 2. Okay, so 5 times square root of 9 is 15. All right, it works. All right, let's try another one here. Now, notice we have x on both sides of the equation. One side, it's inside the radicand. The other side, it's outside the radicand. And this is the type of problem that it's going to be particularly important to check our solutions. You're going to see that we get 2 solutions because we're going to wind up with a quadratic equation to solve. All right, so let's do that. We're going to subtract 5 first to isolate the radical. Okay, now we're going to raise both sides of the equation to the same power. So since we have a square root, we're going to square both sides. Now the left side is easy, right? That just becomes x minus 3. But what do we get on the right side? We've got a 2 binomial expressions, x minus 5. And we're going to square that. So x minus 5 times x minus 5. We basically need to FOIL that right side of the equation. So when we do that, we get x squared minus 10x plus 25. And we simply have our x minus 3 on the left side. Now, this is going to be a quadratic equation. And to solve a quadratic equation, remember this from last year, you need to get it into standard form and everything set equal to 0. So we want to move the x and the negative 3 over to the other side, and so that we have our equation set equal to 0. So if we do that, right, we're going to subtract an x. So that gives us negative 11x. And we're going to add 3. So 25 plus 3 gives us 28. So now we need to factor. Right? So how do we factor that? If we factor this, we wind up with x minus 7 and x minus 4. So the 2 solutions, if you remember, right, how do we solve a quadratic equation? We're going to get a positive 7 and a positive 4. Now, here's the case where we need to check for extraneous solutions. So let's do that. We have to plug both the 7 and the 4 into the original equation. So I'm going to go to the next page here so we have some room to do that. So let's do the 7 first. So 7 minus 3 is our radicand plus 5 equals, and again, we put 7 in for x on the other side. So square root of 4 plus 5 equals 7. Okay, I think this one's going to work out fine, right? 2 plus 5 gives us 7. How about x equals 4? Well, let's put that in here. 4 minus 3 plus 5 equals 4. So the square root of 1 is just simply 1. So 1 plus 5 equals 4. Well, no, it doesn't, right? So it turns out that x equals 4 is an extraneous solution. The correct answer is just x equals 7. So some problems you'll have just one of the 2 solutions that is true, that makes the equation true. Some problems, both of them will make the equation true. Okay, so that's basically it in terms of our strategy for solving equations that have a radical in it, a square root or cube root, okay? And the rest of the lesson, I'm just gonna go through some more examples so you can get a little more practice here before you attempt the homework. All right, so I'm just gonna put this up, let you hit pause, solve the equation, and then I'll show the steps to solve it. Okay, here we go. Square both sides. And this one's very simple, right? We just have to add 3 to both sides and we get our solution. Let's check it. Square root of 100 is indeed 10. All right, next one. Okay, so this one we do need to move the 2 to the other side to isolate the radical. So let's do that. Subtract 2 from both sides. Now we can square both sides. So we get a simple equation and an answer of x equals 3. Let's check our answer. 2 plus square root of 4, which is 2, does give us 4. All right, let's try another one. Oh, cube root. What are we going to do with that? Well, again, let's isolate the radical. So we need to add 4 to both sides. But now, since we're taking the cube root, we want to raise both sides by the 3rd power. So cube root of x raised to the 3rd power on the left, and then 3 cubed on the right. So again, cube root and raising something to the 3rd power cancel each other out. We just have x. And in this case, really nothing left to solve once we do that. X equals 27. Let's check our solution. So cube root of 27 is 3. 3 minus 4 does give us a negative 1. All right, let's try another one. All right. And one more, checking for extraneous solutions. So notice we're going to square both sides, which means we need to FOIL the right side, x minus 6 times another x minus 6. When we do that, we get our quadratic. Now we have to set it equal to 0, so we're going to subtract x from both sides. And we get our negative 13. Can we factor that? Yes, we can. Right. 4 and 9 give us 36 and negative 13. So we have our 2 solutions, 4 and 9. Let's plug them in and see if both of them make the equation true. So we'll put in 4 first. Square root of 4 plus 6, 2 plus 6, is not 4. Okay, so that is not a valid solution. Let's see if 9 works. So square root of 9 plus 6 equals 9. So that would be 3 plus 6, and that one does work. So our one solution is x equals 9. All right, that's it for the lesson. So at this point, you know how to solve a square root equation or even a cube root equation, right? Any index, you just need to raise both sides by that same number. And then for certain cases where we wind up with a quadratic equation to solve, we know how to check for extraneous solutions. Okay, that's it for today's lesson.